So our objective here is this, all right? We're going to solve word problems for using the energy equals Planck's constant times V. And here's our notes that are like, there's going to be 2 sample problems and some things. So let's get down to it. Here's our equation. Energy equals Planck's constant times V. So E stands for energy. Its unit is a J for joules. H is Planck's constant, all right? It's something that's never going to change. It's a proportionality constant. Here's what it is. 6.626 e to the 34th joules per hertz. So this is joules per second, or joules per hertz. This is a really, really small number. It means these things, you need a really high frequency to have a lot of energy. And V, or nu, is frequency, and that's measured in hertz, Hz, okay? Now the pyramid is this. Energy is Planck's constant times V. Frequency is going to be energy divided by Planck's constant, and this is Planck's constant. You shouldn't have to solve for Planck's constant, all right? Okay, here is our first problem, all right? We want to know the energy and of an X-ray, and here's its frequency, all right? So the first thing I would do is my info, and I know my energy is what I want to solve for. I know my frequency, and this is always going to be Planck's constant, 6.26 e to the joules per second, all right? Or it's joules times hertz, all right? Now, the second step is the formula. It's this, E equals Planck's constant times V. So then I substitute it in. So my substitution step is this number times that number. I'm going to plug that into a calculator. I would add the exponent, so my exponent should be around 17. I get this, all right? It's 16. And so that was a good mental math. It was pretty close. And then I'm going to round. So 1 sig fig 4, I'm going to make this have 1 sig fig. So it would really be 2 times 10 to the negative 16th joules. That's my answer, all right? After I've rounded. 2 times 10 to the negative 16th. Once again, that's a really small amount of energy. Just so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, that's how much energy. It's a very, very small amount. Now, here's another problem. Now, this one's a little different because I'm solving for wavelength, and I'm not solving for frequency, but I know the energy. So I'm introducing a new thing here, or I'm going to use this, I'm going to make a plan. I can go from energy to frequency because I know this formula, E equals HV. And then I can go from frequency to wavelength with this formula. All right? So my info, what do I know? Well, I want to know the wavelength, and I need to know, and this is the amount of energy. There's things I know. I know that here's my energy. That's what I want to know. All right, my frequency. I also know Planck's constant and the speed of light. Light always travels at 3.8 e to the 8th. All right? So that's what I know. Now, what's my formula? Well, the first formula I'm going to use is this one, and I'm going to rearrange it for this. Divide both sides by h, and I get this. All right? Now I'm going to substitute in. And I get this, where this is my energy, and that's Planck's constant. I divide them, or I solve them. I get this number. These each 3 and 4, so I'd round it to 3. That's my hertz. and I wrote the exponent in the unit. The unit should be in the over here. But the thing is, if you look back at the problem, I want to know wavelength. Well, to do that, I have to go use this formula where the speed of light is equal to the wavelength times the frequency. And I'm going to rearrange that so that that's equal to this. All right, speed of light divided by the frequency gives me my wavelength. I substitute in, I get this, and then I divide, get that number. All right, and then I would round. This each have 3, so this would be 3, so it would be 6.27 times 10 to the negative 14th meters. Okay, and that's how I would do it. All right, hope this helps.